Folks, welcome back to my channel. I hope you guys are having a wonderful day. Okay, so as you can see, I have written here special case because this is a special case sum. I'm going to formulate this sum using graphical method. But before moving on, I would like to say please subscribe to my channel. I'm completely new, and actually I opened my YouTube channel yesterday. If you go to my description box, not description box, my home page, you will see that it's written joined on February 15th 2020. But I'm actually uploading a lot of videos currently because next week I will not be there. I'm actually going to London for my digital marketing course. My college is taking me over there, so I will be really busy, so I won't be able to post next week. That's the main reason I'm actually trying to cover it as much as I can in this week. Okay, so let's get into this problem. Right, as you can see here, this is max z, that is the objective function 3x plus 1 plus 5x2 subject to 2x1 plus x2 greater than equal to 7, x1 plus x2 greater than equal to 6, x1 plus 3x2 greater than equal to 9. So what is the first step? The first step is simply convert the inequalities into equalities. So let me just write it over here. Max z is equal to 3x1 plus 5x2. This one will remain unchanged. Okay, I'm just writing it for my own convenience, or to be very honest, it looks good that way. 2x plus 1 plus x2 is equal to 7. This one is x1 plus x2 is equal to 6, and this one is x1 plus 3x2 equal to 9. Okay, this is done. Now the next step is I'm going to create three boxes, and I'm going to individually find the value of x1 and x2 for each constraint. How many constraints are here? 3. 1, 2, 3, and 2 variables x1 and x2. By the way, I have written here x2. Here x2 means y. Okay, don't get confused. Okay, so I have drawn three boxes. This one is for this is constraint 1, this is constraint 2, this is constraint 3. This one is for constraint 3, this is 2, and this is 1. Let us find the value of x1 and x2 for constraint 1. So when x1 equal to 0, x2 will be 7, isn't it? When x2 equal to 0, x1 will be 3.5. Now when x1 will be 0, x2 will be 6. When x2 is 0, x1 will be 6. For the next one, when x1 is 0, x2 will be 3 3s are 9. When x2 is 0, x1 will be 9. Okay, so this is completed. Now the next step is I'm going to plot the graph. Okay guys, as you can see, I have drawn the graph. So this side is known as the x1 and this is the x2 side. Let's see the first point, that is when x1 equal to 0, x2 is 7. So when x1 equal to 0, x2 is 7 means this point. When x2 equal to 0, x1 is 3.5. When x2 equal to 0, x1 is 3.5 means this point. So I'm going to join the 2 points. Okay, so I have drawn this. Let's see the second one. When x1 equal to 0, x2 is 6. When x2 equal to 0, x1 is 6 means x over here 6 and 6 over here. So I'm going to join the 2 points again. Okay, I have done that. Now for the third one, when x1 equal to 0, x2 is 3. When x1 is 0, x2 is 3. And when x2 equal to 0, x1 is 9 means this one. So I'm going to join the 2 points. Alright, all the lines are drawn. Now my next job is to find the initial basic feasible solution. Let's go back to the equation now. Okay, so this is the first equation, that is greater than equal to. Let's find this constraint in my line, in my graph. Okay, as you can see, I have marked this line as constraint 1, this one is constraint 2, and this one is constraint 3. And guys, remember, whenever you are plotting the graph, first of all, always try to do it with pencil. I am actually not sitting in the examination hall, that's the main reason I'm using pen. But for you, whenever you're just doing this in your examination hall or any time, try to do it with pencil. Okay, so that was it. And for this one, what I was going to tell you is this is for constraint 1, constraint 2, constraint 3. Now as you have seen, it was greater than equal to, so this is the first line, greater than equal to, somewhere around here. okay, on the right hand side. Let's see the second constraint. Okay, my second constraint as well as my third constraint all are greater than equal to even the first one. So whatever the line is there, like wherever the line is there, it will be on the right hand side. Let's see the graph. So I have already plotted this one. Now for the second one, that this one is for the second line, greater than means somewhere over here, and this one is for the third one, greater than means somewhere over here. Now my IBFS will be somewhere around here. Okay, let me just draw it for you. Okay, I have just drawn few arrows for you to see this. Basically, this is, you cannot move on from this anymore. Why? Because my question is maximization. If my question would have been minimization and this would have been my graph, definitely I could have plotted it. But for maximization, I need a common region which will be like enclosing the entire region. So this is not possible. So what will you, this is a special case. What is a special case? IBFS is not found here. We don't get any optimal solution, and IBFS is unbounded. Use the term unbounded. Okay, so let me just write it. Look, I have written here IBFS is unbounded. If you write just this line, trust me, you will get full marks. Just this line. And oh my goodness, this is, I have written unfounded. Sorry. This is IBFS is unbounded. Okay, so this is done. This is one type of sum which is a special type. I will show you another special type sum in the future, definitely. So in the next video I will go back to normal graphical sums. I want you guys to have a crystal clear view, something like this is always me, this is what I do. Like whenever I learn a topic, just for example this graphical one, I first learned this from one YouTube channel. Okay, so I just tried to solve it, and then I went to another YouTube channel, and then another one. I always, how many, like it's always like so it's yeah, it's always like as many YouTube channels are there, and whoever is teaching this topic, I always visit their channel and I always try to solve their sums. This is what I do. What I do is I take the question, I jot it down, I try to solve it on my own, and then finally I check the answer. So I want you to guys to do that as well, because this is, I think, the 7th video which I will be posting, and I think if you follow all the videos from the beginning, I think by now you would be thorough on this. Okay, thank you so much for watching my video. Thank you so much for having so much patience, and I will meet you guys in the next video with another graphical method sum. Please have patience. Yes, I know it can be possible that you might think that, my goodness, how many graphical method sums this girl is going to post. I want you to be thorough on this. That's the main reason why I'll be posting at least 5 more. Okay, so okay, thank you, bye bye.